This question is from GATE 2022 Mechanical Engineering paper, Set 1, question number 41. In iron carbide, that is Fe3C phase diagram, the eutectoid composition is 0.8 weight% of carbon at 725 degrees Celsius. The maximum solubility of carbon in alpha ferrite phase is 0.025 weight% of carbon. A steel sample having no other alloying element except 0.5 weight% of carbon is slowly cooled down from 1000 degrees Celsius to room temperature. The fraction of pro-eutectoid alpha ferrite in the above steel sample at room temperature is dash. Let's find out. So this is the iron carbide phase diagram, in which on x-axis we can see the weight% of carbon or composition in terms of weight percentage, and on the y-axis we see the temperature. So this is the eutectoid point. Here we can see this is gamma phase, this is alpha plus gamma phase, and this one here is the alpha phase. So it is very important to mark the composition correctly, composition of carbon in terms of weight percentage, in which of the phases is mentioned here. So we can see this here is given to us. So actually if we drop a line from point O, we can see that this composition is given to us as 0.8%. Here at this point where the alpha and alpha plus gamma phases are bifurcated, at this point corresponding composition is 0.025 weight% of carbon, and we are being asked the mass fraction of pro-eutectoid alpha ferrite phase. We are also given the weight% of carbon in a alloying steel, and it is given to be 0.5%. So that can be marked somewhere here, corresponding composition given to be 0.5%. So this particular line from point O towards the right side, and let this point be point P on the left side. This one here be point Q. So this particular line OP is called the tie line, and we can see that all these compositions corresponding to this temperature of 725 degrees Celsius are marked on the tie line. Now to find out the mass fraction of pro-eutectoid alpha ferrite phase in the given steel, we'll apply the lever rule here. So mass fraction of pro-eutectoid alpha ferrite is nothing but this length OQ upon the length OP. To find OQ, we find the difference between 0.8 and 0.5. So 0.8 minus 0.5 upon. To find OP, we'll find the difference between 0.8 and 0.025. So 0.8 minus 0.025. This gives us the answer as 0.387. You can directly substitute this fraction in the calculator to find out this. So let's go back and mark the correct option. The fraction of pro-eutectoid alpha ferrite in the above steel sample at room temperature is option A, which is 0.387. To learn more about phase diagrams, you can refer to the NPTEL video, lecture 33 part 2 phase diagrams. The iron carbide phase diagram is explained in this video very well. This video is from the course Basics of Materials Engineering. The course is taught by Professor Ratnakumar Annavatulla. He is from Department of Mechanical Engineering of IIT Madras. I hope the solution helps you clear your doubt. Thank you.